I think people that are high achievers want to learn and want to work on the highest tech, on the flagships, and want to be implicated as close to the core as possible. And uh, because what we do is, I'd say it's a very impressive thing. I think that people would like to join in our boat and work on the CPU, which is
Yeah.
not many hardware engineers work on specifically the CPU. They work on outside of the whole SOC. And there is also to be part of a early stage startup. You hear all the stories with Revolut, with Nvidia that all became millionaires and
Yeah.
they're all successful right now. So there's also an incentive of it's a risk to reward ratio, basically. Believe in the founders, if you believe in the story, if you believe in the company, then you will be part of it. Because you can't compete with the big corporations only on money.
Welcome to the Siliconomist. Today, I am talking to Darian Domocos, CEO and co-founder of Fiora5. Fiora5 is building the low-power RISC-V processor coming out of Europe. They're for use at the edge and doing it on top of the open source instruction set while still selling commercial IP. I'm excited to dive into that. There's a really interesting geopolitical angle we'll talk about today. I find fascinating you're a European company building toward chip sovereignty, still thinking global and thinking about going to the US market. So, Darian, thanks for joining me here.
Thank you, John. It's a pleasure to be here and to finally have the chance. Thank you.
I'm sure I just mangled Fiora5's business and business model. What did I miss here?
Well, you are pretty close. It's just that we are a CPU company, so we only license intellectual property. So we are not producing the actual hardware, but we help companies that want to manufacture the chips by providing them with a really good and improved CPU intellectual property.
I was almost there. We were going to talk about UU sovereignty maybe, and yeah, we're doing it on RISC-V. So, and the name Fiora5 is connected to RISC-V. Where does the name come from?
It is actually. So I was stumbling across, names when you first make your company. You check to see where is the name. Does somebody else use this? And I like ARM and I like AMD that they are an acronym for something. And pretty much is first implementation of RISC architecture, and then I just put five at first.
Okay, great, awesome. Fiora. It sounds a little Italian. Like it's got a
It is, yeah.
nice rhyme to it almost. So, tell me about the founding story. If I remember, there was a co-founder's experience in the industry, part of a big driver. What was the itch you were scratching, and why couldn't you build it on ARM? Like, why did it have to be RISC-V?
Yeah, so essentially, my co-founder has worked in the industry for almost a decade now, and most of his work is about the chip design, but specifically the CPU, and from microarchitecture design to actually integrating on the client part. So he was on both aspects of the industry, so designing and actually implementation and integration. And he saw recurring issues. So from like ultra high performance cache coherent cores for AI data centers to ultra low power or smart wearable to actually automotive. And it saw multiple recurring issues in terms of for power, in terms of performance, and how difficult it is to integrate them in a client system because it takes a lot of time to integrate these IPs. And it's not just one IP. You have to make sure that it fits with the other, GPUs, the accelerator, all the SOC has to be in a right method to work perfectly. So that's how pretty much his research and development work started as a side, project, as a hobby. And the reason why we chose RISC-V is because it's easier to prototype something. It's easier to start your own than having to license ARM, having to work with ARM. RISC-V, it's an open source standard, so anyone can get their hands on it. And then if you have your own experience, you have many years in the industry, have ideas, it's easy to implement them. It's faster essentially to implement them on RISC-V.
So there's the open source edge there. It's just that anybody can get in. There's no deal has to be cut with ARM to get your instruction set, but you have an open instruction set architecture. What's the difference between sort of the instruction set and the actual chip?
So, the instructions is just a platform. It is an instruction set that the software will run on top on. Imagine you're an architect for houses. So you have these specific rules that the beams should be this big, that you can have multiple rooms, but it has to have at least one bathroom, I guess, for each, like 3 rooms. So it doesn't really matter how you design it. It can be a really big kitchen, an open space kitchen, so with a living room, or it can be really small bedrooms for a student apartment. But in the end, it should respect a certain regulations for the inspection to pass. So it's pretty much the same here. You have the RISC-V instruction set rules, and the microarchitecture. That's where the intellectual property enters the chat. You have anyone can design in their own way. Can be a very high performance, a very high power design, or very efficient one. It just has to respect the RISC-V spec.
Okay, so you like almost like a building code then. If we're sort of thinking about the chip architecture, they give you these guidelines to stay within.
Exactly. And now you have a more specific guideline, which is called RVA23, which is a profile that RISC-V has come up with, that all the software, or the open source software that there is, can run on your hardware if you are compliant with this profile.
The architecture is free. The design is not. The customers are paying Fiora5. The business model becomes I buy an IP block of a pre-designed like processor from you. Is that how it works?
Right. They buy your architecture essentially.
Do you do service on integration and design as well?
Well, usually not. It depends on specific needs of the client. So if you have a really big client that has a larger budget, I think you can do some custom things for them. It's only appropriate, but it has to be in a thought thought out guidelines somehow, because it has to work with their software essentially. You don't want to have the hardware. The hardware isn't that important usually. It's the software that is very important. You can make the best hardware there is. If the software can't run on top of it, it's pretty much useless. So you can do a design partnership with a larger client, but usually the integration is on their side.
So while we're talking about clients, you're focused on high performance general purpose cores and focused on the edge, not cloud data centers, which are hot right now. So you're turning your back on that and microcontrollers. Walk me through what's the business choice there? Why that direction?
So it was when we started. We've done a lot of research. I've done a lot of research on the market. Does it make sense? How much competition there is? And we saw a trend that a lot of companies are right now going for the cloud, as you saw probably. Uh, when it comes to this, is also, do you want to swim in a sea with a lot of sharks? If everyone is running towards the same goal, is that the end goal then? And
Hmm.
or maybe there is an overlooked market. There is something left, and that's how we pretty much saw it. We saw a new category of highly constrained devices, like the new smart glasses, the new humanoid robots, the very critical infrastructure, the autonomous drones, and we believe we can power those because
Hmm.
of our focus on highly efficient design.
So that is it sounds like a very extreme low power play.
It is a still high performance core, so we don't enter the MCU market. We're still an application focused core, but our main focus is on efficiency. A lot of designers can design high performance cores and high power consumption cores. We are focusing on highly efficient ones.
Your website shows automotive, defense, networking, and wearables as directions that you're planning to go. That's a pretty wide spread there. Which of those is sort of the tip of the spear then? Where do you start when you're thinking like low power, high performance
So the beachhead market is going to be the smart glasses and smart wearables, and then
smart glasses?
AI accelerators on edge. So
Okay.
you saw probably companies like Accelera AI and the ones that are doing a edge acceleration and not the cloud ones, more on the edge. So these two are our um, beachhead market that we want to get into. And then in the long run, will probably be automotive as well, because we are an European-based company. So how many automotive companies we have here in Europe?
That makes sense. Yeah. So and the automotive path kind of means like a long validation cycle, right? Like sort of
Exactly.
stay alive financially by going to consumables or to consumer wear and to some of the other stuff that doesn't require such long validation
Right.
and then
Exactly.
keep going with those. When I say automotive is a long validation cycle, I know that there are a whole subset section of standards, right, for automotive. What does that look like? What does a validation cycle for automotive look like?
Well, it is different when we talk about critical safety device, like industries like defense and automotive, because it's not like a consumer. It's the same with medtech. So, when you have your phone, it might have a bug once a week.
Yeah.
You want in cars once in a million years or 1,000 years to have a malfunction.
Yeah.
Essentially, you have the ISO 26266, and you have a few specific grade type of validation called ACLB and ACLD. We plan to be compliant with them in the future years as we progress into the consumer market. With the revenue we generate from there, we can invest it back into the validation of the core to be compliant with the automotive industry.
Tell me tell me about your tool chain. Does it look different than what you would use for ARM tool chain? How open is it, and how do you sort of like decide where the parts stay open and which get closed? How do you design a tool chain to build these chips?
When we talk about tool chains, we think about the software and like, for example, compiler, the tests, the reference models, it's essentially things that are supported by the RISC-V ecosystem. This is like the beauty with RISC-V is that the ecosystem is supported by the biggest players. It's supported by Google, it's supported by Meta, it's supported by Infineon, Quintarius. All of these guys support the RISC-V because they want to flourish and they want to use it. When it comes to ARM, everything is closed. They have a much matured toolchain. They have much mature ecosystem. We can give that to them, but all the investment and all this year that has been done in the research and development for the RISC-V, I think we are approaching the maturity level of ARM at some point. So when it comes to the open source ecosystem, it will remain open source from our part. We do not want to create. We want to be compliant with the RVA23, as I mentioned. We don't want to do any custom instructions that will make it even harder for the clients to adopt us. But what the design will stay proprietary. The design will be Fiora5 owned, and that will be licensed to the clients.
Having this open source tool chain allows you to move fast. If you were on ARM, does it have more features, or is it just more robust in terms of doing a design?
ARM, a lot of the customers love ARM because of their ecosystem. So when it comes to integration, when it comes to testing, debugging, all of the things outside the core. So you might have a really, really amazing RISC-V core, but because you don't have the auxiliary software, the auxiliary parts, it is a bit harder for them to integrate them in their own systems. And it makes sense, It's like having the best car, but it's very hard to open it. Sometimes it has some bugs in it, but it's the most beautiful car. It makes the day-to-day life harder for you. So when those things, when the RISC-V ecosystem will get as mature as the ARM, I think we'll see a really big shift in the market.
See, even more designers going over to RISC-V from ARM.
Yes, right. When I was last week, I had computing. That is, the CEO is Debbie Mark. They just published a paper. I mean, it was like on their website on why they chose RISC-V to win.
Yeah.
And it's quite interesting. It's the same that how x86 started, and then how ARM got very popular into the market, and now RISC-V is accelerating very, very, very much.
What does it need that doesn't exist yet? If you could wave a magic wand at the ecosystem, what would you improve?
I think this standardization of the RVA23 was one of the biggest steps that RISC-V International did, and it helped a lot. I think there should be more standardization. So a hard thing for the RISC-V players before, it was that they had different tools. They had a lot of differentiation between them. It's harder to get adopted when there is not a standard level for this. And again, it's not about just the chip manufacturers, the chip designers. It's about their clients. do their clients have the software capabilities? Do they want to work on RISC-V? Because it's fairly easy to work on ARM. You have, I think, what, 40 years now of ARM. They get used to it. The software is there. Usually what you want is to make the programmer's life as easy as possible. The programmer doesn't care about the hardware that's underneath. They don't want to care. The harder their life is, the harder the adoption will be.
Are you using any of the new AI agent tools that have come out to help code or to help design chips? I think I've seen 3 or 4 where starting to let AI agents do some portion of design. Does that affect your business, or is that possible in RISC-V?
We are a bit reluctant to use AI. I think when
Mhm.
it comes to verification and modeling, it's going to be useful because, you know, you have 100 algorithms that you might choose and you want to test and benchmark them as fast as possible with just a 1% change in this and 1% change in that is it's a long cycle. So to be able to do that really fast, it will accelerate the development, but we are not using at the moment in design. So only in verification and modeling.
One of the interesting things about Fiora5 was just on your website, you have this phrase, born in Europe and built for the world. Tell me about the sovereignty piece. How much of your market is actually driven by the EU?
So we should start by saying that supply chains are global. You know, there
Yeah.
is you want to work with all the with worldwide markets. You don't want to keep your eggs in just one basket. But the local IP ownership for EU companies is a really interesting thing because they don't have to rely on outside and outsourced design. It's easier to facilitate a customer here in Europe because they don't have many alternatives. And sovereignty is not just about the transistors, it's not just about the manufacturing, it's about controlling every little piece in the pipeline. You usually you can't have it all in one.
Hmm.
You go piece by piece, and that's how you get sovereignty. And I think how we started is that we could have done a C corp in the US. Probably it
Hmm.
would have taken us a one day and moved there. But we've seen that the market here is much more open. It's not that there aren't that many players here, and we believe we can help all the companies in Europe to design much better chips in the future.
So you said, and I agree. Chips are a global supply chain, right? So, and they're fabbed all over the world. They move a few times around the world when they're made. Why can't the EU, why does the EU need that? Why can't they just be a consumer? What does sovereignty actually buy them?
I mean, do you want to be just a consumer?
No, that's a fair question. I want some control over my life. The EU just wants more. If you take a piece of the supply chain, then maybe even if it's just design, then you're a player. Is that do you think that's the strategy?
Well, let's think about it from a different perspective. Every continent, every country has their own defense system. So you have, the US, you have China, you have India, you have Europe. All of them have their own defense companies, their own defense systems. How would the defense systems in Europe look with outside chips or outside parts,
Okay.
critical parts? When you have copper wires, it doesn't really matter that much where they come from. But Cypher is one of the biggest developer for defense in Europe. When you talk about defense, you try to minimize the dependency.
The more of it you own, the less likely, maybe not an adversary, but not a friendly can access it or own it, right? But I
You think
still get
about
the
it,
feeling, yeah.
it's
Sorry, go
not
ahead.
only just it's not just about access it. It's just about stopping it.
So you mean
We-
so keeping the supply chain rolling? You don't want it to be turned off. Yeah.
Exactly. It's always good to have the same with food, water, and any important material
Yeah.
for your day-to-day life. It's great to have three choices of water, but when you're in the desert and you have none, you feel it.
Well, do you see the EU getting tighter on sovereignty over time, backing it with import bans or content guidelines or something like that? I think it's reached its peak. Where does it go from here?
I think the world is going to get more tight. We're still gonna work with other countries. I think that's, it's very important. You can't just be by yourself. But it's important to own the supply chain. It's important to have the alternatives. It's important to have your own, pretty much, and not just to have your own. It's to have the best ones at home. I'd say is to invest capital, invest resources, invest in people, invest in knowledge and know-how. It's very important that every country in Europe has the capabilities of learning about AI, learning about microelectronics, learning all these little things, because we don't think about in just 5 years, we think about in 50 years.
You mentioned previously Codicip. It's a Czech CPU hub. It was acquired by onsemi, a US company. It's an interesting path to think about. Does consolidation ever worry you? Does it sort of validate the space for where you want to go, potentially being acquired in Europe or in the US? How does that play into the EU sovereignty side of things?
Well, from my knowledge, they only acquired a part of the Codasip,
That's
but
true. Yes. Yeah. They split it.
yes, but it opened, I think, more doors for us in terms of the CPU. It's also important to mention that we target different application levels
Okay.
than Codasip, so we target a bit of higher performance cores than what they were developing. But but it was an interesting play indeed. I was amazed by it, but also it made sense. It's kind of the same when Synopsys sold their CPU department to Global Foundries. I think we should see what the future reserves for us.
Yeah, so the crystal ball is hazy, right? It's hard to look in the future, but maybe nice to see some cross-continental flow there. Another thing I'm sure that you think about a lot, it's a tough moment to hire deep tech talent, right? Everyone wants the same chip and AI engineers. How do you convince people to come work for a startup kind of coming out of stealth against some of the hot companies that are on hiring benches right now?
Well, it's a really good question. Well, you have to have a bit of money, so you have to pay people a living salary, which is I think it's better than in the US a bit, but but when you work in these really large companies, I think you're aware that you work on a tiny part usually that you
Yeah.
might not ever ship or might not even see in the actual product. I think people that are high achievers want to learn and want to work on the highest tech, on the flagships, and want to be implicated as close to the core as possible. And because what we do is, I'd say it's a very impressive thing. I think that people would like to join in our boat and work on the CPU, which is not many hardware engineers work on specifically the CPU. They work on outside of the whole SOC. And there is also to be part of a early stage startup. You hear all the stories with Revolut, with Nvidia, that all became millionaires and they're all successful right now. So there's also an incentive of it's a risk to reward ratio, basically.
Yeah.
If you
Yeah.
believe in the founders, if you believe in the story, if you believe in the company, then you will be part of it. Because you can't compete with the big corporations only on money, on
Mhm.
salary. So we were very open to having founding engineers be part of the company, so giving them employee stock options.
So that is the bigger bet is like they come in, own more of the company, but also take on more responsibility and have a broader view of what they're building rather than focusing down on one small aspect of the chip.
Right. Exactly.
There's a lot more career growth that way. Just like switching you personally, how did you get into this? What's your path into semiconductor design?
So my story is very interesting. I started working I mean, if we look a bit, I'm very young. So if we look very early, I was part of a robotics team in high school, and I
Okay.
was doing the fundraising. So I was doing actual work on the robot, but I was very interested in the fundraising part because when you're robotics team, you need money to develop the product, and the school did not fund us. So in 1 month, I think I fundraised as much money as they did in their whole history of the team. And I think that's when it started for me to click about this part. And then when I was 17, I started working in an engineering company in my hometown when I was in high school, and it was a medium-sized company. They were doing about, I think, 6 million ARR.
Hmm.
They did ultrasonic sensors. So, for example, in all Formula One, MotoGP, and Dakar will be a sensor that we've worked on, and then also supplying for all the European companies. So I was an engineer there and did some project management roles as well, helping teams, onboarding new teams, and working with finances as well. So I think something clicked in my head there that you can do a lot of stuff very early in your life because I was myself and my three colleagues. So we had a lot of responsibility at a very young age. We basically helped the company a lot.
Yeah. At some point, that confidence became enough to break away and set up your own company. But I
I
think
think so.
I'm hopping ahead there a little bit. Yeah.
No, I think yeah, but
Yeah.
I think so. That I think that's where it started because we were very close with the founder, with the CEO of the company, and he was like a role model for us and helped us a lot. And actually, he just gave us not a lot of like free will
Yeah.
in a company with like 100 employees, and I think that was very crazy at that time. But that's where I met my current co-founder essentially. He was the chief lead engineer of the semiconductor department and we clicked off really well. We just had that spark moment. I was very scared of him. He was too smart, too hard work. But and then we split. I went to university. He went to a very large corporation where he worked on all these projects that I mentioned and was part of the interview.
Yeah.
And we kind of reunited again. I had a school subject about hardware engineering, computer architecture, I think, and I just fell in love with it. I was doing computer science and I just fell in love with semiconductor. So I worked with him, we reconnected, worked with him, and then he explained to me about the problem and we kind of grew in our roles. I told him, okay, engineers don't really like to be part of the company creation, the documents, the administrative work, the HR. So that's how we kind of grew in our roles.
Oh, that's great. I feel like there are a lot of challenges about founding a semiconductor company. It takes a long time to get started and to get rolling. What surprised you about moving into the founder role? What was most challenging about that?
I think it's credibility. It's really hard for a larger company to believe that, two young gentlemen from Romania can actually develop this tech. And I think being in Europe, the risk appetite is really lower than being in the US. In the US, I think companies take a much larger bet on startups. I think that was the biggest challenge that we had. But also, if we look on the other way, the semiconductor industry is really small. So it's very few people. You know them. They know each other. So it's really easy to access the right people. Yeah, and if you are honest about what you do, and if you know what you want to do, and if you are a nice person, I think a lot of people actually want to help you.
You're right. I think in the semiconductor industry, there's a lot more tension than if you were to compare the other extreme, like software, where
Yeah.
you can iterate really quickly and you can do more show than tell before the relationship starts. Then it's a bit more of the reverse here, right? I mean, especially when you're talking about the capital outlay that companies have to do to sort of bring a new product to market. It makes everybody a little bit more risk averse. So that's a tough one to deal with. Well, when you think about Fiora, people are listening, builders, customers, investors. What do you want to take away about Fiora 5 coming out of stealth? It's a big takeaway here.
Well, I think takeaways that we are going to be in the US in autumn. So late of September, where I'm going to be there for the RISC-V International, and I think it will be a great place to meet people when it comes to possible customers, partners, or just people in general. And we are going to prepare for a much larger round next year in Q1. So I think people should have this in mind.
Be lining up to invest, right? One of my favorite questions, or the question I try to ask everybody, is like, what are you reading right now, and what's your favorite resource for learning? Usually, I ask for a semiconductor resource because I'm trying to pick up some design right now. Do you have a favorite book or podcast or website?
So the last book I started, I haven't been able to read it all because
Oh,
a lot
You're
of
traveling.
work.
You're busy and traveling a lot right now. Yeah.
Yeah, but I started reading The Confidence Game by Maria Konikova.
Oh, okay.
Yeah, so
Huh.
the name is The Confidence Game.
Yeah.
I was always very interested in social engineering. So I
Okay.
started my first interest, well, I think it were in cybersecurity, and I got in love with this social engineering and how can people actually play people. And I
Yeah.
think this book really reflects a bit about human psychology, giving real life stories and examples of how there was a man in, I think, in the Korean War that he played a surgeon and actually did surgery on people when he was in war and actually executed them really well, and people believed him. And I think being a founder, this does help you because you want to understand the real motives of people and of the psychology behind it. And I think it's a pretty good book.
Yeah. Well, being a founder is kind of a confidence game, right? Because you're building something that doesn't exist, and you got to get everybody behind you to march towards that and believe in something before it is true, I guess.
Yes, it's the same. I think Mark Anderson from A16Z said this, that when he started his company, he slept like a baby,
Yeah.
woke up every 2 hours and cried. So,
Are you past you must be past the crying point by now.
yeah,
You guys are out of stealth and you're on your way.
yeah.
That's pretty
When
funny.
it comes to learning resources, I think being a Gen Z, it's a bit different. Where I've used YouTube quite a lot, so I
Yeah.
researched, for example, Honor Mutlu's courses from ETH Zurich.
Okay.
That was my holy grail of learning. When
So courses from ETH Zurich. What was the name of that courses?
Honor Mutlu is a professor from
Okay.
ETH Zurich. He's a great professor explaining really good topics. And now I'm pretty much doing what Jamie Dimon from the CEO of JP Morgan does. I'm reading the newsletter of a few
Yeah.
important like websites. Like I do a bit of VC and startup world to
Yeah.
understand where the market is, because when you do a startup, you don't want to be focused only on your
Yeah.
world. You want to have a grand view of the whole world. So I do
Yeah. It
the
takes a
startup
slightly
club.
broader view. Yeah.
Yeah, I do the
Sorry.
startup club, the generalist,
Okay.
semi vision when it comes to semiconductors, and semi analysis. And then the usual stuff like E times and times hardware and RISC-V international,
Yeah.
essentially.
That's a lot of reading there. Where can people find you if you want to follow the latest on Fiora5 as you come out for the next few months? Where's the best place to catch up with you all?
Well, I think on LinkedIn, on my own profile, and then on Fiora5's profile. And we're going to create a new page, a new website, essentially, that will have a more technical approach and view of it, of our architecture, and how much we've done, we've developed the team and everything. So just be patient a bit and check for the new page soon.
Okay. Well, let us know when it comes out. I'd love to follow up and check in a few months anyways. Darian, thanks for joining us on the Siliconomists. And it was great to have you here. And then can't wait to have you back, share about the progress you make in the next few months and check in on Fiora5's story. So thanks.
Thanks a lot for inviting me.